Hello, everyone. In this lesson, we will learn about the implementation of control of motors star delta start using S7-1200 PLC. As discussed previously, when a three-phase asynchronous motor is started directly, the inrush current can be as high as 4 to 7 times the rated current. The larger the motor power, the greater the starting current and the impact and risks to the power grid and equipment. To mitigate this, we use reduced voltage starting methods for larger motors. The star-delta starting method is a common approach because the current during star operation is only 1/3 of the current during delta operation. Therefore, starting the motor in star mode can reduce the inrush current. However, the starting torque in star mode is only 1/3 of the torque at full voltage. Therefore, after the motor starts, it must be switched to delta mode. The transition between star and delta modes typically occurs within 4 to 10 seconds. In the previous lesson, we learned about using timer instructions with the S7-1200 PLC. So how can we use these timer instructions to design a star-delta reduced voltage starting control system for a three-phase asynchronous motor? Let's look at the specific task requirements. We need to control the star-delta starting of a motor. When the start button is pressed, KM1 and KM2 contactors will close, and the motor will start in star mode. After 10 seconds, KM2 will open, KM3 will close, and the motor will switch to delta mode. Pressing the stop button will stop the motor. The main circuit diagram for the star-delta starting is shown. We are required to write a PLC ladder diagram using timer instructions to meet the control requirements. Next, we will implement the task. First, allocate the I/O addresses based on the control requirements, listing the PLC's I/O address assignment table. The table allocates the input addresses and output addresses. Start button SB1 is allocated to I0.0, stop button SB2 to I0.1, and overload FR1 to I0.2. The motor start operation KA1 is allocated to Q0.0, star operation KA2 to Q0.1, and delta operation KA3 to Q0.2. Next, draw the PLC peripheral interface wiring diagram based on the I/O address assignment table. Figure 6.2 shows the PLC peripheral interface wiring diagram. The left side shows the peripheral wiring for SB1, SB2, FR1, KA1 coil, KA2 coil, and KA3 coil. Since the CPU 1214 DC programmable controller cannot directly drive AC loads, the output signals first drive small power intermediate relay coils KA. Then, through the relay contacts shown on the right side, the AC contactor coils are driven. Next, design and write the control ladder diagram based on the control requirements, as shown in Figure 6.3. We will focus on creating the S7-1200 PLC star-delta motor starting project, programming, and online debugging using the TIA portal software. Process for creating a project. 1. Double-click the TIA portal icon to open it. Click Create New Project. Enter the project name, Motor Star-Delta Start Control, and click Create. Once the project is created, click the Configure Devices option. Then click Add New Device. Choose the controller option and select the PLC model. Our PLC CPU model is CPU 1214C DC. Click 6ES7214-1AG40-0XB0. First, define the PLC variables. Double-click PLC variables, then double-click Default Variable Table. In the Default Variable Table, define the variables according to the motor star-delta start control requirements. 3 input variables: Start button I0.0, Stop button I0.1, Overload I0.2, and 3 output variables: Motor start operation Q0.0, Motor star operation Q0.1. Motor delta operation Q0.2. 3. Next, we will proceed with programming. Open the program blocks in the project tree and write the control program in main OB1. During the programming process, when we input I/O addresses that match the defined variables, the variable names will appear. We will use an on-delay timer, TON, DB1, with a time setting of 10 seconds. The operations for the star and triangle shapes will require interlocking. Four. After completing the program, connect the PLC experiment device or use a simulator for debugging. I will use the simulator for this. Click the Compile button on the toolbar, and after the compilation is error-free, click the Start Simulation button to launch the simulator. Download the project to the simulator. Click the Load button. And after loading is complete, click the Finish button. 5. Open the PLCSim simulator and click the Switch to Project View button. In the menu bar, click on New Project and the Create New Project option will appear. Enter the current project name in the project name field. Motor star delta start control, and wait patiently. Expand the project tree and double-click on Sim Table. Then, double-click on Sim Table _1. In the toolbar of Sim Table _1, click on Load Project Tags. At this point, the variables and parameters of the timers we have already defined will appear. 6. Collapse the simulator project tree for easier operation, and also collapse the project tree on the left side of the programming interface. Display both the program blocks and the simulator interface on the same screen for convenient debugging. 7. Open the program block main OB1, click Start CPU, and click Enable Disable Monitoring to monitor the PLC program. The program will now be in monitoring mode. Green lines indicate current flow, while blue dashed lines indicate no current flow. The blue contacts represent a disconnection, meaning their state is 0, while the green contacts indicate a connection, meaning their state is 1. The green coil represents an energized output of 1, whereas the blue coil represents a de-energized output of 0. 8. When the start button is pressed, I0.0 is activated, and the Q0.0 and Q0.1 coils energize, resulting in an output of 1, which starts the motor in star mode. At the same time, the on-delay timer, TON, begins timing. When the timer's current value equals the preset value of 10 seconds, the timer output Q becomes 1. This causes the Q0.1 coil to de-energize, stopping the star operation, while the Q0.2 coil energizes to start the motor in delta mode, switching the operation from star to delta. When the stop button is pressed, I0.1 will open, de-energizing the Q0.0 and Q0.2 coils, stopping the motor. If an overload occurs and I0.2 opens, the Q0.0 and Q0.2 coils will be de-energized, stopping the motor. In this lesson, we detailed the implementation of control of motors star-delta start using S7-1200 PLC. I hope you understand the material well. See you in the next lesson.